Okay, this is a continuation of the last video with the intercepts and the increasing, decreasing, and concave up, concave down, blah, blah, blah. Here's one that's a rational function. Okay, so let's find the intercepts because we're going to graph it at the end. So if I do the x-intercepts, remember x-intercepts is when y equals 0. Now this one's going to be hard because this never can be 0. Because the only way a fraction can be 0 is if the numerator is 0. And that's not going to happen because it's 5. So you can say there is no x-intercept. Okay? That's kind of important. No x-intercept. And obviously you can put this into your calculator and graph it also. And see. But anyway, that's no x-intercept. So the y-intercept, remember for the y-intercept we let x be 0. So y equals 5 over 0 plus 5. And it looks like y equals 1. So the y-intercept is the point 0, 1. Okay. So find any maximums or minimums, points of inflection. So we'll do the derivative. So the function was 5 over x squared plus 5. So f of x is 5 over x squared plus 5. This will have to use the quotient rule. So the derivative is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. All right, and this first bit right here, that's going to be 0. So this is going to be negative 10x over, I'm going to leave it as x squared plus 5 squared. That's my derivative. Okay, and we care about where this is equal to 0. And the derivative is equal to 0 when the numerator is equal to 0. So negative 10x has to be 0, which means that x has to be 0. So my first derivative is 0. I'm sorry, it's going to be 0 at 0. So if I have a negative number, let's just do f prime of negative 1. That makes, if I look at it, negative 10 times negative 1 all over, the bottom's going to be positive, right? Because negative 1 squared is positive. Add 5, still positive. Square it, still positive. So a negative, and we only care whether it's positive or negative. So negative 10 times negative 1 is positive. Positive divided by positive is positive. So it's increasing here. And on this side, I'm going to have, let's just do positive 1. So negative 10 times positive 1, doing the first derivative of 1. And remember, this is still positive on the bottom, regardless of what x is. So now this is going to be negative. So it looks like it's increasing and then it's decreasing. So this is going to be a maximum. Okay, and when x is 0, so when x is 0, remember back up at the top here, what is y? When x is 0, we'll plug 0 in for x squared. So 5 over 0 plus 5 is 1. So this is going to be 0, 1 is going to be my maximum. Okay, doesn't cross the x-axis. Interesting. And my maximum is 0, 1. So if we take a look at it with our graph paper, let me get some graph paper here for us. And since I want to use my graph to show you, I'm going to do this. So y equals, it's a fraction, 5 divided by parentheses x squared plus 5. Close my parentheses. There's my graph. Cute, isn't it? Looks like it's got an asymptote along the x-axis, right? And that makes sense if I remember my rules. The numerator degree is less than the denominator degree, so that would mean my x-axis is a y equals 0 is an asymptote. And look, it's just that little bump in the middle, and then it just kind of keeps going and going and going. Notice it crosses the y-axis at 1. So that's what my sketch would look like if I had to sketch it, which I do. So let's go back. Symmetries, it looks like it's symmetrical with the y-axis, right? Remember it did this. Right, you gotta make the sound so you can see that. Okay, this was my y-axis, and then this was my x-axis. That's what it looked like. And I would encourage you to use your calculator to find out what it looks like, and don't be afraid to zoom in. So symmetry along the y-axis, and then if I have to graph it, here's a graph already made for me. Personally, if I were going to do this, I would get rid of this 10, right, so that I could do whatever I wanted to do, because I might want to make this here be 1 so that I could have some interesting motion to it. Okay, it doesn't have to be perfect, just has to sketch it. Okay, so just make sure you label a point or two on your x or y axis. I don't care. So we got some symmetries. It's all with the y-axis. If I reflect over the y-axis, now notice this one. If I had to find inflection points, notice it looks like it's if I this is concave up, and then it's going to change and start to be concave down, and then it would change back to concave up, right? So if I had to find those points of inflection, it looks like it would be on either side of the y-axis. It didn't ask me to do that, but maybe I want to do that, and that would be the second derivative, right? So if this is my first derivative, let me just snag this out of here, copy. Let's go down here and let's find, just to practice, our second derivative. Okay, so our second derivative would be the bottom, so x squared plus 5 squared times the derivative of the top, which is negative 10, minus the top, which is negative 10x, times the derivative of the bottom. Now the bottom, the derivative is going to be, because I have to use the chain rule, 2 times x squared plus 5 to the 1 times 2x. And then that's all over the bottom squared, so really it becomes x squared plus 5 to the 4th power. So if I had to do this, I'd probably multiply this out, and I would get x to the 4th plus 10x squared plus 25 times negative 10. This is going to be really ugly, and so on and so forth. I don't want to do it anymore. It's too messy. I'd leave it like that, but I'd have to solve it for 0. But anyway, we could do that another time. Maybe I wouldn't multiply out the x squared plus 5. Maybe I'd factor it out to find it. Anyway, that's not on your final. That's just algebra exercises. So anyway, good luck. I'll talk to you later.